All right, here is our sort of graphing basic logarithms intro. So you should have just watched a video that explains what a logarithm is and its connection to exponential functions. So in the previous video, we talked about logarithms and exponential functions being the inverse of each other. So that inverse is, I think, kicking it back to the 4th week of our class. So as a refresher, inverse functions are functions that undo each other. So for example, if I have y equals x plus 2, so my input I add 2, my inverse would subtract 2. So y equals x minus 2 would be an inverse. And thinking about what these tables would look like, so I have x and y, and then I have x of my inverse. If I had 0, 1, and 2, if I plug 0 in, I get 2 here. 1 plus 2 is 3, and this will give me 4. My inverse is the exact opposite. I can plug in 2, 3, and 4 and get 0, 1, and 2 out. So just sort of a really quick refresher about what an inverse function is very basically. So here, if I want to graph y equals log base 2 of x, and I want to figure out what this looks like on my graph, I want to come down here and I want to look at the relationship between logarithms and exponential functions. So if I have log base 2 of x, that's the same thing as 2 to the y is equal to x. And thinking about when we're talking about inputs and outputs, this is really like 2 to the x is equal to y if I'm thinking about inputs and outputs. So what I can do is I can go ahead and I can plug these values into my exponential function. So 2 to the negative second power will give me 1/4. This will give me 1/2. Anything to the 0 power is just 1. This gives me 2, 4, and 2 cubed is 8. So when I graph my logarithm, I can come over here and I can flip-flop my inputs and outputs. So now I can input 1/4 and get out -2. I can input 1/2 and I know that I would get out 1. Excuse me, not 1. I can input 1/2 and I would get out -1. I can input 1 and get out 0. Input 2 and get out 4. And I can input, going backwards here, input 1 and get out 0, input 2, see, look at this. I am messing myself up here. So really I'm just, flip-flopping these back and forth. So I can input 1 and get out 0, input 2 and get out 1, excuse me, input 4 and get out 2, and input 8 and get out 3. So if you look, these y's match these x's, and these x's match these y's. So I just went ahead and I flip-flopped. So I can come up here and I can plot 1/4 comma -2. So if this is 1/4 comma -2, I can plot 1/2 comma -1, and then I can plot over 1 and up 0, over 1 and up 0, over 2 and up 1, over 4 and up 2, over 3, and I'm up there at, excuse me, over 4 and up 2, and down here over 8 and up 3, so 1, 2, and 3. So when I graph this, it ends up looking like this. And if I were to come over here and in green, graph what my exponential function would look like, -2 up 1/4, -1 up 1/2. Then I'm down here over 0 and up 1, over 1 and up 2, over 2 and up 4, over 3 and up here at 8. If I were to come over here and plot this, I can see that these are inverses of each other and they reflect nicely over the line y is equal to x. And I know that my exponential function has an asymptote here at 0 And really similarly, my logarithmic function has an asymptote over here when y is equal to, when x is equal to 0. So we can really see the similarities and the differences between these logarithmic functions and these exponential functions. So for example, if I wanted to plot y is equal to log base 5 of x, the first thing that I would do is I would make a table for the exponential version of this. 5 to the x power is equal to y. And again, I would plug in -1, 0, 1, and 2. So -1, that's going to give me 1/5, 1, 5, and 25. And I can come over here and make a table for my logarithm, and I can just flip-flop these values. So x and y, 1/5, 1, 5, and 25, -1, 0, 1, and 2. So I can then go ahead and plot this instead of thinking of numbers where I can find nice sort of fifth roots of them. So what I'd like you to do now is there's a Desmos activity that's posted for you with a classroom code. So you'll go to student.desmos.com, and I'd like you to work through that, type in thoughtful responses into the response boxes, and notice some connections between how we shift things around. And when I say shift things around, I mean how we change some values within the logarithm and how that shifts around or changes the shape of the graph. And then there's a problem set for you to go ahead and do some graphing on. So I would suggest going and checking out that Desmos activity next.